The title of our presentation is Histological Image Classification Using Deep Features and Transfer Learning, presented by Sadiq Alinsaif and co-authored with my supervisor, Professor Jochen Lang. The goal of this paper is histopathological image classification. Only small well-annotated histopathological datasets exist. When using deep learning models, particularly convolutional neural networks, the rule of thumb that we need large number of datasets. Therefore, we study and compare the applicability of CNN as feature extractor and transfer learning, or so-called fine-tuning of some or all layers of a model. We use pre-trained models as feature extractors or weight initializers. We use 4 models in our study: SqueezeNet v1.1, MobileNet v2, ResNet 18, and DenseNet 201. CNN as feature extractor. For each histopathological image, we extract 4 sets of features. Each set of features are ranked using infinite latent feature selection. Finally, we use support vector machine for classification. Details on feature extraction. We use the deepest layer, the layer that is just before the classification layer, to obtain the feature vector of a histopathological image. While we use these pre-trained models, we do not apply any fine-tuning. Infinite latent feature selection, or ILFS. This feature ranking technique is based on graph theory. ILFS considers features as nodes in a graph connected via paths. ILFS considers all possible paths among features to investigate the redundancy of any features. Second approach, transfer learning. It has been shown in the literature that transfer learning can deliver better results than training from scratch. Therefore, we use the same 4 pre-trained models to retrain for histopathological image classification. We use 4 datasets in our study. Please note that Abisroma, Warwalk, breast cancer histopathological dataset, or BRCHIS are binary classification problem. However, Cather's dataset is 8-class classification problem. We validate our model in the context of cross-validation and then report the accuracy and NUC. First, we report the results while using deep features. When we use ILFS, we use increment of 50 descriptors at a time. Then we report the results while using top-ranked features that achieve comparable or better results as using all descriptors. Please note, we show the results of multi-class Cather's dataset only because of the time limit. DenseNet deep features achieve the highest results to classify Cather's dataset. We note that with feature selection, we can achieve comparable results as using all descriptors. Now, we report results while retraining all layers of a CNN model as a classifier using multi-class Cather's dataset. We noticed that the smaller models can achieve better results with fine-tuning, but DenseNet reported a slightly lower accuracy. Finally, we examine module-based fine-tuning of both SqueezeNet and ResNet. First, we report the result of fine-tuning SqueezeNet while using Cather's dataset. We observed that we do not need to fine-tune all modules to obtain an accuracy as fine-tuning all modules. We noticed the same observation when fine-tuning ResNet 18 modules. To our knowledge, the state-of-the-art result of classifying Cather's dataset achieved by Bianconi et al. They use a modified version of local binary pattern that consists of inter and intra descriptors. The reported accuracy is 93.4%. However, our strategies have achieved better classification results on Cather's dataset. Conclusion: when we examine the classification of different histopathological datasets using deep learning approaches, we solve the classification of Brecques, Warwack, and Abyss-Roma datasets, and we even deliver higher accuracy for Cather's dataset than previously published studies. We show that both CNN-based descriptors and fine-tuning approaches can deliver high accuracy results. CNN-based deep features demand feature extraction and reduction, but with lower computational resources. On the other hand, CNN as a classifier can be retrained end-to-end, but with high computational resources. We would like to acknowledge the support of both the National Sciences and Engineering Research Council of Canada and the Saudi Cultural Bureau in Canada. Finally, here are the references. Thank you for listening.